Hi guys, this is Vineet, and in this video we will talk about how you can create indexes with included columns in SQL Server. Let's proceed ahead. So before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel, as subscribing gives us huge motivation to create new videos for you and for other SQL professionals. Right now I have around 323 subscribers with 132 videos on my channel, and this list is increasing. I want subscriber count somewhere near 500 at the moment, so need your help and support here. So please go ahead and subscribe. In order to subscribe, there is a subscribe button below this video pointed to by this arrow. Click on that subscribe button, you will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. On the right hand side, you're seeing an animation showing you how to subscribe, like, and get notified regarding the videos. So please watch this animation. And over the top you see that out of 100 viewers, only 4% of them are subscribing to our channel. Rest of them are not. So I would urge you guys to please go ahead and subscribe to my channel. Now there are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice. Perform any exercises in your lab environment or test environment. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our video, so please share your comments. We would love to read them. And in case you need the PDF copy of the notes that are discussed during this video, there are two methods. First method is you can pay a nominal fee by going to this link, topmate.io link. You can go there and make a nominal fee payment to get the PDF copy of the notes. Another way to get notes is to send me an email showing me the proof of your subscription to my channel. You can take a screenshot from the below the video where you have subscribed to my channel. You can in the screenshot you can take video name along with subscription proof and my channel name, and upon receiving your email I will send you the PDF notes copy. So second method is free basically, and you can get PDF notes for free. First one is the paid method, and the link is also included in the description in order to make payment and get the notes. Now let's move ahead. Now I have some playlists to watch. So we have database design playlist, business continuity videos playlist, SQL Server indexing playlist. You may watch all these three playlists as per your liking and as per your domain. So business continuity videos are related to disaster recovery. Database design videos, as the name is suggesting, are related to database design. And the SQL Server indexing playlist contains videos related to SQL Server indexing, which comes under performance tuning basically. But performance tuning also includes other topics in addition to indexing. So I've just created this playlist just for the indexing videos. And apart from that, the fourth link is my channel link, which you can open up in YouTube, youtube.com/@SQLDocs by Vineet. That will take you to my channel page. From my channel page, you can also subscribe to my channel. And if you have any questions related to SQL Server, you may ask them so by paying a nominal fee of INR 500 for a single question. And you can ask them questions at the below link. The link is there in the description. And if you need any help with writing profile while preparing your resume, I'm available for a consultation with an hourly charge of INR 1000. And you may avail this service by going to the link below. The link is also included in the description. Now let's come back to the topic. I hope you have already subscribed to the channel. Now today's topic is how to create indexes with included columns in SQL Server. Let's go to my notes quickly. So today's topic is how to create indexes with included column. Let me select my pen pointer quickly and then we'll begin. Now today's topic is how to create indexes with included columns. Now this video will demonstrate you how you can add included columns. Basically these are non-key columns, the columns which are not used as keys in the table. So those are non-keys columns, and these are also called included columns. To extend the functionality of non-clustered indexes. So basically included columns can only be used with the non-clustered indexes, not with the clustered ones. So that's the limitation or restriction, you can say, if not limitation. So included columns can only be used with the non-cluster indexes in SQL Server. And we can include these non-key columns by using the SQL Server Management Studio or Transact SQL. Now by including the non-key columns, you can create an non-cluster indexes that covers more queries. So what's the benefit of including the non-key columns? By including the non-key columns, we can create any non-cluster indexes that covers more query. What do we mean by covering more query? This is because non-key columns have the following benefits. So non-key columns can be of a data types not alone allowed in the index key column. So there are certain columns which we cannot take them as an index key while creating the index. So any of those columns, or maybe you can say majority of those columns, can be included as included during the index definition as included columns instead of the key columns. So those will be non-key columns, but yeah, can be included in the index definition as well, but not as a key column. They are not considered by the database engine. So database engine do not consider the non-key columns or included columns when calculating the number of index key columns or index key size. So database engine performs two operations. First, it calculates the index key size. It's basically the size of the index key for one particular row. That's the index key size. Basically is the size of all the key columns combined, their data types. So it takes you to the index key size. So the database engine does not consider any non-key columns during the calculation of index key size, and also it does not consider while calculating the number of index key columns. Now an index with non-key columns can significantly improve query performance. So the benefit of using included columns is that it can increase the query performance when all the columns in the query are included in the index definition, either as key or non-key columns. So basically it is saying when all the columns in the query, so whatever columns are referred to by the query, if they are included in the index, whether in the key columns or in the non-key columns, we get performance benefits. Now performance gains are achieved because the query optimizer can locate all the column values within the index itself. So how the performance is achieved? Performance gains are achieved. Why? Because the query optimizer can locate all the column values in the index definition itself, within the index itself. Table or cluster index data is not accessed, resulting in fewer disk I/O operations. So if we have included non-key columns in the index definition and we have a query referring to those columns, the query will not perform a table scan or a clustered index scan while accessing those columns, or when accessing the resulting rows in, and data can be accessed in fewer disk I/O operations. So first benefit is that query optimizer will be able to locate all the columns within the index itself, and therefore table or cluster index scans are not required, which basically are costly operations in terms of disk I/O. Now when an index contains all the columns referenced by the query, so here we are talking about an index that contains all the columns that is referenced by the query, it is typically referred to as the index covering the query. It is called index covering the query, we can say, if it includes all the columns that are referenced by the query. Now there are some design recommendations for these type of indexes with included columns. So what are those design recommendations? Let's read them one by one. So first recommendation is to redesign any non-cluster indexes that have large index key size. So we should always redesign any non-cluster indexes that have a large index key size. Index key size should be smaller. That should be our purpose. So why is that purpose? So that only columns used for searching and lookups are key columns. So index key should be smaller. that is beneficial while creating the index if your index key size is smaller, because that index key column is used for searching and lookups. Those are the key columns that are used for searching and lookups. Make all other columns that are covering the query. So we should make all the other columns that are used in the query into the non-key columns or included columns in the index definition. In this way, you will have all the columns needed to cover the query, but the index key itself is small and efficient. So index key should always be small and efficient. So we should try to use less number of columns in the index key, and basically the columns which are omitted from the index key can be included as included columns in the index definition. Now let's come to next point, so which is suggesting include non-key columns in a non-cluster index. So it is saying that include any non-key columns in a non-cluster index to avoid exceeding the current index size limitation of a maximum of 32 key columns and the maximum index size of 1700 bytes. So currently SQL Server 2016 and beyond, we are allowed to use 32 columns as key columns. If we are taking composite keys, 32 columns are allowed, and the maximum size of the index key should not be more than 1700 bytes. For SQL Server versions prior to SQL Server 2016, the limit was 16 columns and 900 bytes instead of 32 key columns with 1700 bytes beyond SQL Server 2016. The database engine does not consider any non-key columns when calculating the number of index key columns or index key size. So this is the main point. So database engine does not give any view to the non-key column or does not consider any non-key columns when calculating the size of index key or the number of columns used in the index key. Now the order of the non-key columns in the index definition does not matter or does not impact even the performance of the queries that are used in the index, that use the index. Let me go through it again. So while defining the index, we mentioned the non-key columns as included columns. So during the definition, the order of non-key columns does not matter and does not even impact the performance of queries that use that particular index. Now the fourth point is we should avoid a very wide non-cluster indexes. What do we mean by wide non-cluster indexes? Wide non-cluster indexes are the indexes that can include multiple columns. So those are called wide non-cluster indexes, where the included columns don't represent a narrow enough subset of an underlying table columns. If adding wide indexes, always verify if the cost of updating one extra wide index offset the cost of reading directly from the table. So we should compare the cost of updating one extra column in the index in comparison to the cost of reading directly from the table without any index. So it should provide us benefit. If they are costing us more, we should not be using such type of indexes with more and more columns included as a part of key column. Now let's discuss about some of the limitations here. So non-key columns can only be defined on the non-cluster indexes. They cannot be used with the clustered indexes. And all data types except text and image can be used as non-key columns. So we cannot use the text and image columns as non-key columns. We cannot use these type of columns. Any other data types can be used efficiently or effectively. Computed columns that are deterministic and either precise or non-deterministic. Let me repeat again. Computed column that are deterministic and either precise or imprecise can be used as non-key columns. Now computed columns derived from image and text data types can be non-key columns as long as the computed column data type is allowed as a non-key index column. So what are allowed as a non-key index column? The columns which do not have text and image data type. So the resultant column should not be of text type and text type or image type if they have to be included as a non-key index column. Now non-key columns cannot be dropped from a table, so we cannot delete any non-key columns from the table unless we remove the index from the table. So index from the table should be dropped first if we have to delete any non-key columns on which the index is based. Last limitation is non-key columns cannot be changed except to do the following. So we can change the nullability of these columns from not null to null. Another thing we can do is increase the length of the column if it's varchar, nvarchar or var binary type column. Now there are certain permissions required to create this index, and creation of these index require the alter permission basically on the table or view on which we are creating the index. And user must be the member of fixed server role or the DB DDL admin or DB owner fixed database role. These are the permissions required. And let me take you through the demo. Now in this demo we will cover how you can create an index with non-key columns using the SQL Server Management Studio, as well as how you can create an index with non-key columns using the tsql statement. So guys, let me start SQL Server as I have to do the demo. So I've launched the instance of SQL Server. Let's give it a few minutes to launch. Waiting for it to launch. So now it's launching. Now what we are doing is we are creating an index with non-key columns using the SQL Server Management Studio. So we are opening SQL Server Management Studio. We will log on to our instance. So we are logging on to default instance of SQL Server. On the left hand side we have Object Explorer. Now in the Object Explorer we need to click the plus sign to expand the databases section. So databases section is expanded. Basically we need to expand the database that contains the table on which we want to create the index. For example, let's take sample DB. I'm expanding the table section, and under each table let's see what all indexes we have. For the student table we don't have any indexes. For test table we have some indexes, so let's not use the text table, but we can use either of employees or student table. Now we have expanded the sample DB and we have expanded the tables on which we want to create the index with non-key columns. So if we talk about columns here in the employee table, let's add another column. So maybe we can go to design of this. Let's add another column here. So we have employee name, employee ID. Employee ID can be used as primary key. So this is a key column, we can say, and although indexes are not defined and this is not defined as primary key as of now. And let's add age as well as a column. So we have 3 columns and all 3 of them are non-key columns, right? And we can take this as int data type. So alright, and it can allow nulls, but employee ID is not allowing the null values. Now let's close and save the definition, and we have set the definition. We can refresh the table here and columns here. So we have 3 columns in this table. Now we have clicked the plus sign to expand the table folders, and click the plus sign to expand the table on which you want to create an index with the non-key column. So in order to create the index, what we can do is right click on the indexes folder. So here we don't have any index as of now, so right click on the indexes folder, go to new index, and we can select the non-cluster index option here, and it will open up a new index dialog box here, and it takes us to a general page. We need to enter the name of the new index. So right now it has selected non-cluster index. Let me mention with included columns, maybe included calls, I can say. So maybe we can mention the name of the included column. So in our case, let me take age and employee name, age and int name maybe. So we are taking these two non-key columns, although all three of them are non-key columns because employee ID is also not having the cluster index key. So we are taking these two columns only, the employee name and the age, as non-key columns or the included columns. So after you enter this information, under the index key columns, we need to select the columns on which we are creating the index. We have clicked the add button. Now in the select column box, select the checkbox or checkboxes of the table columns or columns to be added to the index and click OK. So here I'm just taking employee ID because that will be our key column. So I'm taking this employee ID as index key column. Other columns can be used in taken in the included columns tab. So employee ID will be our key column. It's in ascending order, and under included columns we are taking the other two columns which are non-key columns. That can be employee name or age. Employee ID is a key column here, so that is included under the index key column, and in the included columns we have all the other non-key columns. So after doing the column selections, and we can click OK after that. So this will create an index for us, non-cluster index. So this is the index created where the non-key columns are age and employee name, and the key column is key column is employee ID. Alright, so that's how you create the index with the included columns via SQL Server Management Studio. Now let me show you how you can use transact SQL to create index. So here let me see, let's use the AdventureWorks 2022 database here. So we are in the Object Explorer and we are connected to a database instance. Let's select AdventureWorks 2022. Let's select new query. Now you need to write some SQL code with me. So in order to create the non-cluster index, we use the create non-clustered index statement, and you need to mention the name of the index. So here I'm mentioning the name of the index starting with IX, and we are mentioning the name of index as IX underscore address underscore postal code. Let's use this index, and we're creating this index on, let me show you the table. We are creating this index on person.address table. So let's see, we have that table. So we have person.address table, and we can expand this table, see the columns here. So any index is present, we can check it here. So we have quite a few indexes created on address, line 1, line 2, city, state, province, postal code, and that's a unique non-cluster index. And some of the indexes are already created basically. So what we are doing right now is we are creating a non-cluster index with some included columns. So those included columns, so let's see if we have any index matching. So this type of address is already present, which is this, and it's let me see this properties of this index. We will basically create this type of index. So here index key columns are quite so many, included columns are not there. So I think it would be I'm not dropping this index which I already created. So I'm creating a non-cluster index. Index name is IX underscore address underscore postal code, and I'm creating this index on, I need to mention the table name, which is person.address is the table name here, and we need to specify the column. So column name would be postal code, which will be the key column. So I'm creating a non-cluster index with key column as postal code, and I'm including any non-key columns in this line. so we can mention the non-key columns here. So I'm using all those columns, other columns, maybe address line 1, I can include it here, address line 1, and let's use the address line 2 as well. So address line 2. Apart from that, we can use the city maybe, and maybe the state province ID can be also be used, which is a foreign key. So but I'm still using that as and that column as an in the included column list. So state province ID I am including here. So that's the end of our statement, and we just need to execute this statement to create this index, and the key index will be created. The key column of that index will be postal code, and any included columns will be, we are taking 4 columns: address line 1, line 2, city, and state province ID. I'm not taking the other, some of the other columns like spatial location, row grid ID, modified data. I'm not taking that. I'm just taking address line 1, address line 2, city, and province ID. Let me quickly run this query to create an index. So index is created. We can refresh the index section to see this index. So we can see here index name is ix address postal code. So it is created here. It's a non-unique index and a non-cluster index, and it's an included index. So we can check the properties. What are all the included columns and what are all the key columns? So key columns are just postal code, and included columns are these 4 columns. So guys, we have shown you how you can create indexes with included columns using the SQL Server Management Studio, as well as using the transact SQL code mentioned here. And let me go back to notes. I hope you like this video. Today we have discussed about how you can create indexes with included columns. We have given you a brief overview of that, and apart from that, we have discussed some design recommendations while creating indexes with included columns. Apart from that, we have also discussed on some of the limitations that can occur while including the non-key columns while creating indexes. And we've also discussed about permissions required to create the index, and we have covered 2 demos. And I hope you like this video, and if you really like it, click on the like button and do post your comments, and do share this video with your friends in case you feel this video is useful for them. And once again, please go ahead and subscribe to this channel. It will hardly take few seconds. There's a subscribe button below this video. Click on that button. You will get bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And apart from that, please go ahead and watch my playlist. I have several playlists. On one is on SQL Server indexing, another one is on business continuity, and third one is on the database design videos. And database design videos has around 40 videos, and business continuity has more than 45 videos, and indexing playlist has around like 3 to 4 videos. We have just started, so it will also have many videos in a short span of time, maybe another month or 2. You will have around 40 to 50 videos in the indexing playlist as well. So keep on learning, guys. Thank you so much for your time, and you have a wonderful day ahead. Thank you.